So just before we start into today's lesson, we should maybe look at assignment 2, part 2. Now, you're probably not going to be able to finish it at this point. We're going to need content from both today's lesson and next week's lesson, but you can certainly get started on it. So the document's already on Blackboard, but I want to review exactly what you'll need to do for part 2. Again, you'll be using the same solution. So the same project, same Azure link, same GitHub repository. You don't need to create anything new. You will for part 3, but not for the next part. Okay, so it's due in 2 more weeks. Again, 5 o'clock on the Tuesday, April 2nd. So not next Tuesday, the Tuesday after, 13 days from now. So again, just submit the same 2 links again. So I don't have to go and try and find them. Same Azure link, same repository. A warning about this. This is somewhat less of an issue in part 1. It becomes more because assignment 2, part 1 is pretty simple. You basically just follow the steps. You hardly had to write any code. Okay. In part 2, you have to write a lot of code because you're going to have to write a bunch of unit tests. Now we're going to write a suite of unit tests together for the Everything Store today and next week. Next week's class is actually going to be an in-class lab. So today we're going to sort of set up our Everything Store. We'll write a few basic unit tests. And then next week, I'm going to divide the class up into groups, and each group is going to have to write one section of the unit tests that we're going to need. So that when we compile them all together, that will basically give you all of the tests that you would need. Now there's a warning. In assignment 2, part 2, where basically you're writing unit tests in your assignment, in the assignment you've built, I do not want to see the unit tests that were compiled for the lab copied and pasted with the words changed. You actually have to write the test yourselves, even if the code is similar. If you just take the stuff that I post, change the words and give it back to me, I'm going to know, and I'm not going to mark it. Okay? It's going to be pretty clear. So just to be clear about what you have to do, you're going to have to create a test class for one of the 2 controllers in your assignment. You don't need to unit test both of your controllers, only one. Okay? You're going to need to use the mock NuGet package. I'm going to show you how to use that today. We're going to implement it in the Everything Store today. You'll then need to write unit tests for one of your controllers to get as close as you can to 100% code coverage. Okay? And we'll look at the code coverage tools in Visual Studio, as well as another optional tool to show you how to do that. Okay? You don't have to get exactly 100%, but you should at least be able to get in the 90 percentile for code coverage. Okay? You will need to make roughly somewhere in the neighborhood of 24 tests to do this, depending on what functionality is in your controller. You will need at least 20 unit tests for your assignment. Okay? Again, I want to see at least 4 new commits on GitHub. And then you just publish to Azure again. We're going to refactor a lot of the code. So there's a risk that we'll break things here because our application right now is not really set up to run proper unit tests. So in order to set it up, we're going to have to break a few things and redo them. So all I'm going to check on Azure is that once your unit tests are running, your website still runs. Not just that the test passed, but that we didn't break the site and it's still working. So we've got 2 weeks to do this. Does anybody have any questions about assignment 2? Okay. So next week's class, we'll do the quiz, and then we'll do the lab. That probably will be the whole class. Okay. But the lab is due, so it's a group lab, and it's due at the end of, due in class. You don't get to take it home, but you don't have to do it yourself. You get to work together with other people. Okay. Let's go here. So I know that unit testing is not a brand new concept for you, so I shouldn't have to explain too much about what it is. You've done unit testing before. Whose class did you do it in? Java? Who was your instructor for that? Garrett, Ben. Okay, so when you hear the word unit testing, what things come to mind? What do you think about? It's the first thing that comes in your head when you see that term. What else comes to mind when you think of unit testing? Okay. Think of unit testing. You've all done it. I can wait. I'm patient. Okay, good. Sorry, input validation, you said? What else do you think about?
So using answer.
Okay. That's one of the steps in a unit test. What else do you do within? What do you do in a unit test before you assert? Assert is usually the last step of the test. What happens before that? Right, so that's known as act, right? We actually execute the code. Okay, Mike, you mentioned another important point. Okay. Why do we remove the data? Okay, yep. It's also a different kind of test if our database is actually involved. What kind of testing is it if we're testing our application in connection with our data, combined with our database? That's no longer a unit test. That's something else. What kind of test is that? We've got our application over here and our data over here, and we're testing how they work together. Like, for example, if a query result actually fetches the data we expect. Sorry? Close. Even closer. It does start with an I. What would be called? Unit testing and integration testing are two separate things. As Mike said, unit testing, when we're unit testing, we have to divorce, we've got to remove the actual database. Because if we're working with our live data, it's not a unit test. We're then testing the integration of our database and our application, which we want to do, but that's kind of a separate thing. The point of unit testing is we want to test all of the logic and methods in our application, and we will leave the database out of it and make sure that the logic works. Anything else you think about? What's the goal of unit testing? What are we trying to accomplish? Cynthia? Okay. So we have to think about what do we expect our application to do. And then the unit tests are designed to show us if our application is going to behave the way we've expected based on different circumstances. How do we know when we're done? There's another important concept of unit testing. I mentioned it when I went over the assignment. Because theoretically, we could test forever, couldn't we? We can never run out of things to test, in theory. So at what point, Mike? Right. So that's an important concept, right? Oops. Code coverage. So most testing environments, they have some kind of tool that will show us what percentage of our code is covered. So that's why in your assignment, on one of your controllers, I want you to get either 100% or in the 90% of the different execution paths that we can say are covered. This is also really important, not just when we're developing an application. Arguably, it's actually more important when our application is already in production. The unit tests become perhaps even more important. Why would it be more important for an application that's already in production use, potentially? Where's the value in having unit tests? Okay, yes, that's one possibility. We want to make sure our errors are handled. But we built an application, we've gotten paid for it, we've launched that application, we have lots of users. Unit testing becomes really important now. Why would we need to unit test something that we've already put into production and is being used? Who cares about the tests at this point? Didn't we do all the testing before we launched it? Why would it matter afterwards? Yes, we would do compatibility checks, but we'd probably do that even before our application was in production. So we launch our application tomorrow, right? March. Tomorrow's the first day of spring, right? So, and then 6 months from now in September, lots of people are using our application. So why are the unit tests valuable at that point? Okay, you're getting warmer. Not exactly what I'm thinking of, but Nehal, you're getting closer.
Try to destroy one of the logic, it will just tell us the health of the application.
Okay, good points. If we build an application and we launch it tomorrow on March 21st, lots of people are using it. What are the chances we're ever going to have to make changes to that application? Pretty high. What would be a scenario where we have to change it? Why would we ever have to change it? Okay, we find a bug. Why else do we have to change it? Okay, performance. So it's working, but it's not working as fast as it needs to. Why else, Mike? Yeah, new features, right? If our application's popular, probably we're going to have to build onto it. Oh, you were going to say something else? Okay, so keeping it up to date, new technology, right? If it's a web application, maybe it doesn't respond as well to with a new version of jQuery or a new version of Chrome. So there's all kinds of reasons why our application might need to be updated, even if we built a good application. So why would unit testing be important in those scenarios? Those are all very good and common reasons, right? I mean, I woke up 2 days ago and the first thing I saw, picked up my little Galaxy 7 and Android said, right, install the update. So Google sent an OS update. So that happens all the time. If we build a successful application, we're going to have to update it, patch it. If Apple and Google and Microsoft have to patch and update their software, well, so will we. Fair assumption. So how does unit testing become really important in that scenario? We found either there's a bug, we need updates, technology changes are forcing us to change things. Unit testing really matters in this case. Why? Yep, true. Now, if we make a bunch of updates, so let's say we made 5 updates for the various reasons we just talked about. Are we just going to unit test those 5 changes that we've made? Why not, Emilio? Right. That's the big one. You hit it. Thank you, Emilio. It's not enough for us to test the things we've changed. We have to make sure when we've made changes today that we didn't break other features that have been working all along. Right? It's not enough to just look at what did we change, because when we make a change here, it could affect something over there that used to work. This happens all the time. This is also a good reason to use version control like GitHub. So if we break something today that used to work, we can go back to it. Right? We have GitHub archives. So unit testing, not only for updates, but also to ensure changes don't break old code. This right here is the most serious problem when we update applications. Particularly when we wrote that application a long time ago, or somebody else wrote it. We either forget what happened in our old code and we don't realize that a change we make over here is going to break something, or maybe it was done by somebody else because that original code base was old. So we're not even familiar with it, which means the chances that we might break something that was working before is even greater. So unit testing is our defense against this. Right? When we make changes, we can go back and test the whole application, as Emilio said, to check the consequences of the changes we're making today. So it's super important. This is probably the single most important reason why we need to unit test. Okay. There, I knew you could do it. Just need a little prodding. So what we're going to do, we want to unit test the everything store. Now, some companies even practice what's called TDD, test-driven development. What's test-driven development? We're not exactly going to do that. It's a little late for us to do that. Does anybody know what test-driven development means or how it works? Or what do you think it might mean based on the name? Yes, that's true, but they're done in a particular point in the development process. When would the unit test be written in test-driven development? Before the code is written or after? Yeah, Lynette. In test-driven development, the developers actually write all the unit tests first. They figure out this is what the application should do, and here are all the possible execution paths. And we're going to write all our unit tests first. And then we write the methods based on the unit tests. So it's a kind of reverse way of thinking, but many companies have adopted this approach now. Right? So we write the code to match the unit tests, not the other way around. We've already got a working store, so it's a little late in the semester for us to try that approach, but you should be aware that it's out there. I would bet in the next 3 to 5 years, some of you are going to go work somewhere where that's how you build everything. And if that's ever you, send me an email. I want you to come back to class and give the class a guest talk in a few years, explain how TDD works. So what we're going to do, I've kind of borrowed 2 different tutorial series. This one's a little bit old. This one actually talks about test-driven development. This is also about a 50-minute YouTube video where they take a .NET MVC application and then implement unit testing with mock data, which is what we want to do. We're going to use this package called mock. which we'll install. Really popular, over 49 million downloads into .NET projects. So the idea here behind mock is it allows us to temporarily disconnect our application from the database and use some in-memory fake data instead. And that way we can test all of our CRUD methods in our controllers without actually being connected to SQL Server. So we're going to want to unit test all of these things, right? These are all the methods that Visual Studio scaffolded. We need to figure out what unit tests we're going to need. And then we'll write those tests together over the next two classes. Okay, so let's open up the Everything Store. I actually have a few, not many, but a few PowerPoint visuals for you guys today, just to help kind of chart out what we're doing. So let's open up the store. And we'll get it loaded. So Visual Studio has a bunch of built-in tools. It has a unit testing framework called MS Test. There are some third-party testing tools. I'm going to install one of them in Visual Studio, and I'll show you both tools. And you can use either one. You may even find another unit testing framework you prefer instead, and if so, that's fine. So I'll just launch the store. And I'll just keep this open during class. We may refer back to it a few times. I'll save this image to Blackboard later as well. So you'll notice, if we look in our Solution Explorer, right down at the bottom, the last item here, we actually have a unit testing project already. We did this because when we created the Everything Store back in like week 2, there was a little checkbox that said add unit tests in the window where we create the project. And I asked you in your assignment to make sure you check that box so that we're now at the point in the semester where you want to write unit tests in that project. So by checking that, right, our solution shows 2 projects, the web application project here, which shows in bold because that's the primary project. And then this one, which is not bold, here's our unit test project. So if we expand it, we can actually see what's here. So when we check that add unit test box, Visual Studio generated this project. And in here, we actually have a controllers folder. And you'll notice there's actually a controller in here. And it's got the same name as one of the controllers in our web project, except it has the word test on the end to tell us this is a unit test class. We can open that up. So it references the Visual Studio unit testing library, makes a reference to system.web.mvc, and notice it also references the controllers of our web project. So this way, this class can unit test any of the methods that we have. And close up my views. We don't need the views today. So we can test any of these controllers. So there's an annotation here above the class that says this is a test class. Okay, so the purpose of it is for running unit tests. And there's actually 3 unit tests already here. Index, about, and contact. If you remember, these are the 3 original methods when we create a new Visual Studio solution. Right, in the home controller, it creates an index, about, and contact method in view. So when we choose add unit tests, it generates a unit test for each one. And each method also has this test method annotation above it, right? So this indicates this is a single unit test in here. And the structure of these unit tests, all that comes back to what you mentioned, assert, right? So the structure you can see is in the comments in green. So every unit test has these 3 steps: arrange, So set things up. Any variables, any objects we need to instantiate happens in the arrange. So here, we're instantiating an instance of the home controller. Somebody else mentioned, I can't remember who it was, right, that we were going to, I think Michael may have been you, who said execute the code, right? So that's our act. So we're actually going to call the index method in this test. And we're going to store what comes back, which is a view result. That's what we expect to get back. And then lastly, we're going to do an assertion. Right? Did we actually get something back? Now, this isn't really a great unit test. Why not? True. Well, let's look at the assert line in particular. If we want to call the index method, all this is checking is that we didn't get back a null object. That's not really a great unit test, right? If this method returned the number 4, the unit test would pass because all that's coming back is something that isn't null. So what would be better? What would be a more specific unit test we could check for, a more specific assert, instead of just asserting it's not null? Well, we're calling index. If our index method returns the about view or the contact view, will our test pass or fail the way it's written? Annette? Will it pass or fail? So we call the index method, and the index method returns the about view. And then our assert is checking that the result is not null. Will that pass or fail? Right, it will pass. As long as we get any view back, this test will pass. If this returns the about view, should this test pass or fail? It should fail. Why should it fail? Yeah, it should fail unless the view we get back is called index. If it returns any other view, the test should fail. The way it's written right now, as long as we get something back, it passes. So we probably should rewrite this test. And we will. Then we test about. About is a bit different. Here, we're actually checking that the view bag message is equal to this. So that's a little bit better of a test. And on contact, it's really the same as the index. Not great. As long as we send any view back, this test is going to pass. So let's run these. So to run our tests, there's a few ways we can do it. Easiest way is if we just click on the test menu and click run, I'll choose all tests. So this is going to build the solution automatically in case there's any uncompiled code. It will always build. Well, I think we can turn that off. And then it pops open a new window we haven't seen before called Test Explorer. And it shows us that the overall result was successful. And if we drill down, it ran 3 tests. In our home controller called about, contact, and test, and each one of these unit tests pass. I'm going to open up the home controller in my web project. We'll look at a couple of the other tools that are here. If I go back to test, I have this other option that says analyze code coverage. So that's down here near the bottom in my test menu. I'll click analyze code coverage and all tests. Unfortunately, this feature is a little bit annoying because it builds and runs all the tests again. And then it gives me this down at the bottom, code coverage results. So our application is 3% covered so far. And if I drill down and expand and go to my everything store controllers, So in our home controller, it says we're 60% covered and 40% not covered. The other thing I can do is I've got this little button here that says show code coverage coloring. It's the second last button beside the red X. If I turn that on, you'll notice now in my home controller, we get some blue highlighting and some yellow highlighting and some red. So what do you suppose the blue, the yellow, and the red would be indicating? Okay, yep. So what would the blue be indicating, do you think, specifically? Yeah, so covered. That code is completely covered by unit test. Okay. Red, that should be fairly obvious. Not covered. So yellow, partly covered. Okay. So let's play around with some of these methods and some of these tests a little bit. So again, our index test is checking that we get back a view, any view. So let's say our index, I'm going to change this, instead of returning the view called index, our index method is going to return the view called about. I'm going to build and rerun my index test. So I can just rerun this one test. If I just right click it, I can choose run selected test. Now my test has passed. So this is kind of the benefit of test-driven development, right? We've written the test after the fact. The test isn't really a very good one though, because this method is returning a view called about, and my test says, okay, instantiate the controller, call the index method, get a view back, and make sure that view isn't empty. So it's not a very good unit test because our test is passing, but we're not accurately checking. What should we assert instead? Let's rewrite this. What should we check instead of just checking that the result isn't empty? What do we actually want to check for? Yeah, so we actually want, we'll use this first method, R equal. R equal takes two parameters. What are we expecting and what did we get? So what is the name of the view we should get back? So in quotes, we're expecting index. And we can check the result dot view name. Right? What we're getting back is a variable called result. It's of type view result, so it has a view name property. So this is a better test. I'm going to run it again. What do we expect will happen? Pass or fail in this case. It should fail. I'm going to rerun it. So here we've got the correct, the expected index, but we got a view called about returned back to us. So this is how a unit test should properly be written. Generally, just checking that something isn't null isn't probably a great test. We want to be more explicit about what our test should do. So in this case, our test tells us, hey, there's a problem with the code. The index method should be returning the index view, but it isn't. So this gives us an easy way to now go and fix our code. So if I just take that out. Notice the other thing that Visual Studio gives me. It actually tells us here, there's one unit test on this method, and the last time it ran, that test failed. Okay. Our about has 1 of 1 passing. And our contact also has 1 of 1 passing. So if I click on this, it actually shows me any tests directly for this method. So now I can just even run it from here. Okay. Now that's interesting. Our test still failed. And notice the message now. I put the code back the way it was originally to just return view without anything here. But now what we got back is our view name is actually empty. So this is showing up as nothing. Good solution, Mo. So let's run it again. Now I'm actually specifying the name. My test passes. So when we call our method from the browser, we don't have to specify the name. If the name of the view matches the name of the method, which it does most of the time, the browser will render the proper view. But the unit tests want us to be more explicit. So one of the things you're going to need to do, we're going to need to do, and you're going to need to do in your assignment, is all of the return view statements, all of the empty return view statements, you're going to need to explicitly name the view the way that we just did with index. Okay? Otherwise, those unit tests where we're checking that we're loading the correct view, yeah, right, I mean, they'll all fail. Okay? So we're going to need to do this. This will need to be like return view create, and return view edit, return view details index. So the scaffolding does not do that, right? Our return view statements don't contain the name of the view. So that's one thing we're going to need to do to make our unit test pass. So let's just go to let's write a couple more tests here to try and improve the code coverage. So we have a method for about. So we are checking that we get the proper message in the view bag. But we should probably also have a test that makes sure, like with index, that when we call about, we get back a view result, a view also called about. So let's write another test here, and then we should improve contact. Let's try and get 100% or closer to 100% code coverage in this simple controller. So I'm going to write another method here. I'll write a test method. I'll try to be more descriptive. This is what we want to test. The about method actually loads the view that's called about, just like we did with index. We'll arrange, insert. Now the way this is structured is right now we're arranging the same thing in every method. Each one of these methods, the arrange is instantiate an instance of the home controller. We do have a test initialize method where that method will run before any unit tests. So we don't have to keep repeating the same initialization code over and over again. We'll do that later. So again, we'll create an instance of our home controller. We'll expect to get back a view result. And then we'll assert that what we get back is a view called about. Exactly the same line we wrote on the index test. We'll use R equal, we expect about. We'll compare that to our result W. So notice now, this test shows as blue, meaning it has never been executed. If it had been run before and successful, it'd be green. If we'd run it before and it failed, it'd be red. So I'll just run this one test. We'll see what happens. Okay, our test failed for the exact same reason as our index test failed. Our about method does not explicitly name the view it's returning. So we want to specify the name and rerun our test. I'll run it again. Now let's rerun the code coverage. We should have increased from that 60%. We should be closer. We won't be at 100 yet, but we should be closer. Unfortunately, this code coverage tool has no refresh function. You have to run it all over again, which is super annoying. Nick, I'll take your question in just one sec. So let's see where we got. So now in our home controller, okay, we're at 62%. So about now is 100% covered because there's two things that happen in about, right? It sets a view bag message and it loads a view called about. So we've now unit tested successfully both of those things, and that method's totally blue. So about's 100%, contact is at 92. Nick, you had a question. What's happening? So you clicked on tools, test, run, and all tests. Okay, I'll have to come look at it. There is another testing tool you can try. I'll give you another tool. Some students prefer it. I'll install it. You guys can see it. So go to Tools and NuGet Package Manager. Sorry, it's not a NuGet package. Tools and Extensions and Updates. If you click Online, up here you can search for a tool called AXO Cover. This is a third-party extension for unit testing. So some of you may prefer this to the built-in Visual Studio testing tools. So you can install this if you like, but when you install an extension Visual Studio, it forces you to close Visual Studio. So you have to close it, and then when you restart it, then the extension installer will pop up and say, okay, you downloaded this extension, do you want to install it now? So you say, okay, you wait for it to install, and then you have to reopen the project. So you can give that a try. Some people who have issues with the testing tool, like you're having, Nick, have better luck with this one. So once you add it, I already have it in mind. I'll show you what it looks like. Now it's available to me under the Tools menu. So if I go to AXO Cover, I can basically run the tests and see my code coverage through here. So it gives me similar kind of window. So I have 4 tests. I haven't run any of them with this tool yet. So it says none have passed, none have failed. So if I just click the Run button, it runs them through this window instead of over through MS Test. And if I go to Coverage, it's executing. If I go to Cover, it's under Report. So it does similar sort of thing. So it actually says, let's see our home, let's see our, So it's still got our home controller at 60%. But it says about, contact, and index are all covered now. Fully. Okay, so it has a little bit of different logic. You may get slightly different numbers with this tool. You can use either tool or another unit testing tool. There are other extensions. You don't have to use these. It's up to you how you want to do it. Okay. So those are, well, I'm going to leave the products out. We added these because these are connected to our database. And again, for unit testing, we don't want the database involved. That's integration testing. It's not unit testing. So we've looked at kind of the basics of how this works. So what we're going to do, I think it's about time for us to have a break. When we come back, we need to look at this. How do we substitute in some fake data and remove the database so we can unit test our methods without actually working with our real data, where potentially we may break something, which we don't want to do. So we're going to look at installing this, and then we're going to need to create a new class, test class, and we're going to have to set up using that mock data, and then we can start writing a bunch of unit tests to work with it. Okay, so we'll start that at 12:30. Yep. There we go. So that's our one new unit test. So we just rewrote the about and index. We just modified the assert statements to be more explicit. Actually, I have one last question for you, and then we'll take a break. Why did I write two different unit tests for about? Couldn't we have written one unit test to test both the view bag as well as the name of the view? Why write it as two separate tests? Yes, can you be more explicit, Nick? You're right, that is why. Right, so this is one of the principles of unit testing. Each unit test should, technically you're allowed. I could write 20 different assert statements right here. But the problem is, then it becomes an issue of we have to evaluate each one, pass or fail. So in order for the test to pass, as Nick said, if we have two assert statements, both of those asserts would have to be true. And then if it gets complicated, what if one fails and the other passes? Or one passes and the other fails? In that case, our test fails, but that doesn't help us so much fix the problem. So the idea is we should actually write one assert statement per test. So if the method we're testing does 10 different things in that method, we should have 10 different unit tests. And we want to test each individual thing that method does in isolation. That will make it much easier for us to fix if we have a problem. And that's why in your assignment, again, here are all the methods. We've got 8 methods in one controller you're going to test, but you're going to need about 25 unit tests to write all of the individual assert lines that we need. Right? So it's going to be more, it's not just one test per method. It's generally multiple tests per method. Unless that method is like our index view that only does one single thing. One test is enough here. But for everything else, there's going to be multiple tests. Okay, I'm going to stop the video and step out, catch up on a couple of things I need to do, and I will post what we've done so far to GitHub right now.